This is a video from Math 120, section 2.1. We'll be talking about secant and tangent lines and their slopes. So a secant line, if you remember from geometry, if you had a circle, the secant line is one that touched in 2 points. This is secant. And a tangent line touched in 1 point. That's tangent. So if we're looking at a curve, maybe just a parabola, if we want a secant line, you put a line through 2 points, P and Q. And this would give us a secant line. The slope here is called the average velocity. So for a tangent line, since the secant line touches in 2 points, the tangent line through P would be one that touched in just 1 point. So this is the tangent line. And that would give us the instantaneous velocity. And that's only if we're looking at the slopes. So we want the slope of the secant line and the slope of the tangent line. So I'll remind you that a slope, m is equal to y2 minus y1 over x2 minus x1. And this is the same if you're looking at a graph as rise over run. So let's see the difference between the average velocity and the instantaneous velocity here. So if we have P and we have Q, we can get a secant line, and the slope of the secant line has been computed here to be negative 1.01, and the slope of the tangent line is computed to be negative 0.681. So they're definitely different slopes. But what I find is that if Q approaches P, and this time Q is on the left, so this would be approaching from the left. Sometimes it's said below, and we mean below is in terms of the x values. So as Q approaches P from the left, we can see our slope is getting closer to the negative 0.681. And as Q gets closer and closer, we get even closer there. And we're almost to the point where it looks like it's the same line. We end up with the secant line and the tangent line having pretty close to the same slope, certainly within 2 decimal places, negative 0.68, negative 0.68. Now if I'm approaching from the other side, so move P and Q, you can see here the slopes can be vastly different between the secant line and the tangent line. So if I'm approaching from this side, as Q goes to P from the right or from above on the x values, we get very close to the slope of the tangent line if we compare slopes. So if we take one, like for instance right here, this is pretty close to the tangent line. It's still a fair amount of difference in the slope. But as Q gets a little bit closer, there's less difference between the two numbers. Even less difference, they're getting closer and closer, so the slopes are getting closer. So you can estimate the slope of the tangent line by using a secant line. So why would we want the slope of a tangent line? Well, I notice here that if I can figure out the slope right here at the high spot, at the maximum, that's where it would be teeter-tottering level. See, it's real hard to get. 0.002 is pretty close to level. If I could figure out what that slope is by using the secant, then I could figure out where the maximum and minimums are on my graph. I could also do this for the minimum down here. I can get pretty close to it being level, within 0.003. So this is a horizontal line, and the horizontal line has a slope of 0. So again, what we're looking at is the tangent line. Tangent line just barely touches the graph in one point. You could see that better at the maximum and the mins because it's teetering on the top or the bottom, whichever case. So if I could just get my P to approach, the Q to approach the P close enough, if I can get it close enough, I can make a pretty good estimate of what that slope is, either from the left or from the right. And sometimes we say the left is below because it's below in the x direction, and the right is above because in the x direction it's Q is above P. Q would be down here for the x value, and P is here. All of the exercises in WebAssign for this section are about getting the secant line slopes. So we're going to calculate some secant line slopes. Now, to do slopes, we'd have to do, for each one of these 4, we'd have to do an equation of the slope, which is the y2 minus y1. So for this one, we'd have to do for 42 and 36, we'd have to do 2943 minus 24 over 42 minus 36. So that'll get a slope. You get it pretty quickly, but I'd like to show you a way to do them really quickly in your calculator. So we'll go to Stat and Edit. We're going to put in these pairs of points, but I'm not going to put in 42 because here all of these are between 42 and the other points. So I'm going to leave 42 out because I want to do in the second column the slope of the secant lines. So the slope between these 2 points is really what we're looking for. So I just type in the numbers, and I'll check carefully to make sure that these are correct. But what I did was Stat Edit, and I typed in all the numbers except for the 42, because 42 is what we want the secant between. So basically that's like our P on the graph. So that would be the P there, and the Q is elsewhere. And they're doing both left and right here. So they're doing numbers that are below 36 to the left of 42, and they're doing numbers to the right of 42. Well, one number to the right of 42. So this might give me a pretty good estimate as to what that slope should be. So now I want to calculate the actual slope between these points. So I'm going to go back to my paper. Now the slope of the secant is really just the slope between 2 points, y2 minus y1 over x2 minus x1. It's just an average velocity. The slope of the secant line is the average velocity. So if we instead put in where we have these values in the calculator, and what I know is that I want, from my point, this is my P. It was given to me on my set. So it was at 42 and 2943. Now all my x2s and y2s are in list 1 and list 2. So I want x2 and y2 to be here. So this is the same as x1, y1. On the test, I will have you do a problem like this where it'll be very fast to do on your calculator. It'll be kind of tedious to do it without the calculator. So in list 1 and list 2, so now I can write my slope formula as being list 1, list 2, so it's going to be list 2 minus 2943 over list 1 minus 42. So what's going to be different here every time is this point. So the point will be given to you the problem, and you should be able to do it pretty easily on your calculator. So if we go back to our calculator, at the tippy top of list 3, so really pay attention here, if you go up to the tippy top where the list 3 number is, you can type a formula in here. And I'm going to need some parentheses. So here, what I really need is to put parentheses here and parentheses here. So I'm going to put in parentheses, and that's above 8. I want list 2. Notice the list 1, list 2, and list 3 are above here, above the 2, 1, 2, and 3. So if I do a second list 2, that's where my y values are, minus 2943, and you of course have a different number on your exercise set. I'm going to close the parentheses because that's my y2 minus y1, and then divided by, in parentheses, list 1 minus 42. So second, list 1 is above 1, minus 42. But that's whatever number you have. Now when I do this, it's going to compute all 4 of those slopes at one time. So 6 one, half a dozen the other. Some things are going to be harder or quicker or faster or maybe a lot easier or a lot slower, depending upon how you're doing these in your calculator. Now every keystroke had to be here. You had to be up at the tippy top of the list. You have to put in your slope, and I recommend you write it down first, even on the test, so I can give you some partial credit if your numbers are incorrect. So if I hit enter, it gives me all the slopes that I need for my exercise. So I can go back to WebAssign and put these numbers in one at a time. So between 36 and 42 would be between 36 and 42 is already in there because we put it in the formula. So that'd be the 29.833. Now note that they say round your answer to 1 decimal place. So make sure you only leave 1 decimal place here. For problem number 2, they want me to do all these numbers 0.5 to 1.001. So I'm going to clear out my list here. If I hit clear, it'll clear the list. Go up to the top, hit clear, it clears the list. To the tippy top where that is, where the label is, the list name, I hit clear and enter, and that clears out my list. So I'm ready to start with a clear list. So these are my x values, 0.5, 0.9, 0.99, 0.999. And then it starts 1.5, 1.1, 1.001. Now they didn't give me what I'm supposed to use for my y values here. They only give me x values. So I'm going to also have to compute my y values, and they give me a formula for that. Now everywhere there's an x, I'm using list 1. So for list 2, I want it to be list 1 divided by 8 plus list 1. So in the tippy top again, I'm going to put, I don't really need the parentheses for the list 1 on the top, but I could put it in if I'm not quite sure. So I'm going to put second list 1 divided by, I do need the parentheses for the bottom. If you're not sure, put them on the numerator and the denominator. 8 plus second list 1. So everywhere I have an x, I'm going to put a list 1 instead. That looks pretty clear, right? So we get these y values in, and now we have the same setup we had for problem number 1. This is more like what you'll see on the test. I'll give you the x values, you're going to have to compute the y values, and then for list 3, you're going to have to do the slopes again. So the slope, remember, is y2 minus y1, and this is my x1, y1 here, 1 and 1/9. So I'll put in parentheses, I'm up at the tippy top, parentheses, I'm going to put second list 2 minus my y value, which they gave me was 1/9, close parentheses, divided by parentheses, list 1, second list 1, minus the 1. Now notice on my list here, 1 is not included, but I'm using values that are going from the left, it's going to 1. So 0.5 to 0.999 goes to 1 from the left, and then 1.001 to 1.5 goes to 1 from the right. So 1.5 to 1.001 going this way, going down, is going to point P rather, from the right. So we hit enter and we'll get all the slopes we need for this. So these are the actual slopes that they want you to put in here. Now the important part of this exercise is that you're trying to find out, correct the 6 decimal places, what the actual line is supposed to be. Now you notice here it's only showing 4, but down here it shows more than 4. So you'll have to scroll down to get one of each of these numbers to 6 decimal places. So make sure you're doing that. You can see all 6 of them here. If I compare the two at 0.999, I get 0.098776. And if I compare the one that's close to 1 down here, 1.001, I get 0.098754. I could estimate the instantaneous velocity by taking the average of those two numbers. But there is kind of a quicker way to do it. Since in list 2 here I put what the y value was, I could go to my graph and see what my instantaneous velocity actually is. This will be x divided by parentheses 8 plus x and then I want to graph this and take a look at 1. So I'm going to graph and I want to see what the instantaneous velocity is at 1. So if I do second calc, and this one down here, it looks like a slope. The difference in y's over the difference in x's, that's 6. I want it at 1, so I'm going to put 1 in. And notice it didn't ask me for the 1, so let me do that again. Second calc, 6. It doesn't give me any information about what it wants here. You just have to know that you need to type a number in here. So this gives me 1, and this gives me 0.098765. I'll go back to my stats. In the third column here, 0.098765, 0.098765. So these were both a little further away at 0.098765. They're about 10 away in these digits. 76 instead of 65. And at the bottom it was a little further away the other direction. In question number 3, they actually give you the interval to work over. So this was more like working between the points in the first problem. So they give you what y is, so you'll need to put this in the equation in list 2. And they show you that you want the average speeds over these intervals. The 1 is actually going to be your p, and you'll have to put that 1 in here to figure out what the y value is, which is your y1. So the 1 and whatever that y value is would be the point p. So your x1 is 1, your y1 is putting 1 in here, which you can just about see what that is, putting the 1 in. Then they ask you to estimate the speed here when t equals 1, and I just showed you how to do that on your calculator. So you should be able to get an estimate either way. Notice that this is going from the right. It's above 1, so it's going 2, 1.5, 1.1, 1.01, 1.001. So if we were looking at a graph like this, the q would be from the right and working towards p. The numbers are above the x values for p. Number 4 actually has some trigonometry in it, so let's take a look at how you do that on your calculator. We need to make sure that in mode we're on radians. So you can see radians degree. Make sure you're on radians. The pi is over here above the caret. So I should just be able to type this in. I could type it in y1, so then I'd be able to see it pretty easily. So I have 3 sine. Notice it opens parentheses, so I need second pi. My calculator uses x, not t. I need to close the parentheses, plus 3 cosine second pi and x again. Now I could look at the graph of that and figure out what the instantaneous velocity is at this point. I wouldn't have to put that in. But let's actually go to stats and figure this one out. So there won't be as many things here. Remember to clear. This is to go to the tippy top where the list name is and clear. Don't delete because it deletes it off the screen. I'll show you what I mean. If I go up to the tippy top and hit delete, it takes list 1 off, and then I'm kind of upset for a little while. But you can get it back. You can go to stat, go to 5, hit enter, Then you go back into Stat, Edit, and you get your list 1 back. So go to the tippy top, I'm going to clear it. So clear is the word you're going to want to use here for clearing out the list. I don't want to delete it, I want to clear it out. So my Y1 is going to be 1, my X's are there. Instead of putting the formula in for list 2, I'm going to use what I just put in Y equals. See, Y equals already have my formula. Since I already have it, I was thinking about estimating the instantaneous velocity. Then if I use the formula here, because I already have it typed in somewhere else, it'll make it a little faster. So I can just do Y1, and you're either going to need to go vars, Y vars, and then function Y1, which is how you would get it on TI-83, or you can do alpha trace if you have an 84 with the new operating system, and Y1 is there. But I already have it in there, so let me just hit enter. I have to delete one amount now. If I hit enter now, oops, went too quick. I have to give it an X value. Now this is function notation, so I have to have a parentheses, and I want the X values to be the ones in list 1. Second list 1. I'll close that out and enter. So now I get all the Y values that I needed. There they are. So I need a slope, and we know that the same formula we were using before, I don't actually know what the point is at 1, so I guess I'm going to have to figure that out. So let me go out and figure that out. Second quit. I can again use Y equals, or I could go to the graph. I could go to the graph and have it calculate. So let's do that. Go to the graph, and there's what my sine and cosine put together look like. If I do a second calculate now, I want a value, and they want the value at 1. I get -3. So the value at 1 is -3. So going back to Stat, I'm going to put in for my x1, y1, -1 comma -3. So I need in parentheses -3 minus list 2, second list 2. It should look really familiar now. Divided by, don't forget to close your parentheses, and then it's 1 minus second list 1. So there I'll have all my slopes. So I'm thinking as I get closer and closer to 1, my slope should be about -9.41. And according to this list, that might be the best estimate I can get. So I could check that, especially if I'm not sure I've done it correctly. Going back to 6 here, I check it at 1. Notice it didn't ask me, but I want the slope at 1. That's what this says. I want to estimate the instantaneous velocity at 1. So I do this and I get -9.42. So most likely they're looking for you to have the best estimate that you have from these numbers, but it could be they want you to have that -9.42. So it may take you 2 tries to do that one. The problem I give you to work on the test will look like this. So be prepared to do a problem that's very similar to this one with just a list of X values.